Hey guys, so what we are going to cover today, so this is your notes video for Wednesday, 11-20. We are going to cover taking the derivative of exponential and logarithmic functions. So there should be e and ln x, obviously we've already covered the derivatives for. But we are just going to kind of review some things about these guys. So when you take the derivative of e to the x, okay, the derivative of e to the x is e to the x again. Now, when I do the chain rule, the derivative of e to the u is e to the u times u prime. Okay, well, the other option for taking derivatives is you can also take the derivative d dx of a base other than u. So, if this is a base other than e, then basically you're going to still have that same base to the u. You're going to still multiply by u prime, but then you have to multiply by a natural log of whatever that base is. So, for example, let's say that you were taking the derivative d dx of 3 to the x squared plus 5. Okay, the first thing that you should notice is that my base here is a 3, not an e. So when I take the derivative of that, it's going to be 3 to the x squared plus 5 times the derivative of x squared plus 5, which is a 2x, and then multiplied by an ln 3, where 3 is the ln of the base. Okay, let's do one more like that, number 2. d dx of 7 to the sine x. Okay, well, and I would say, all right, well, I noticed that my base is a 7, it's not an e, so the derivative of that is 7 to the sine x. Remember that my core up here stays the same, but then the derivative of sine x is cosine x. And then, because my base wasn't an e, it was a 7, I have to multiply by an ln 7. Okay? So if you were to take a look at your homework, I'm not going to do a bunch of it, but if you look at your homework 8 for today, which is right here, and you go ahead and look down here at the bottom, you're evaluating each of these derivatives, so these should be super easy. So let's say I'm taking the derivative of number 5. I'd say, okay, well, the derivative of 3 to the x is 3 to the x times ln 3. Number 6, derivative of 2 to the sine x is 2 to the sine x times chain rule, derivative of sine x is cosine x times the ln of 2, etc. Okay? Now, the other thing you need to know how to take the derivative of is logs other than natural logs. So remember, d dx of ln x is 1 over x. Okay, well then what about d dx of ln u? Okay, so if instead of just being an x, it's a function u, then it'd be 1 over u times u prime. Okay, now, the alternative to that would be you could just put the u prime over u. That's typically how I'm going to do it. So the derivative of ln x is 1 over x. The derivative of ln u is u prime over u. Well, then the derivative of log base b of u, where this is a base other than e, which is the base for a natural log, would be u prime over u, ln b on the bottom. So rather than multiplying by your ln for this one, you actually have to divide by the ln of whatever that base was here. So 2 more easy examples here. Let's say we're taking the derivative d dx of log base 5, 6x squared plus 3. Okay, well then think about this. This is my u. So if my u is 6x squared plus 3, what's my u prime? Okay, well the derivative of that would be 2 times 6 is 12x, plus 3 goes away. And then remember, my derivative needs to be u prime over u times ln of the base. So in that case, it would be u prime is 12x, and then my u is 6x squared plus 3, and then my ln of the base is ln 5. So let's go back to that exact same part of the homework and let's work through one of those. Let's say we're doing number Let's do number 9. Okay, so I have log base 2 of 3x to the 6 plus x. Okay, well then if this is my u, remember I want u prime over u ln b. So my u prime on the top, 6 times 3 is 18, x is now to the 5. Derivative of plus x is a plus 1, all divided by. Then my original u is still a 3x, 6 plus x. But then because this isn't a natural log and it's a log base 2, I have to put an ln of 2 on the end. Now let's say, for example, that I was doing number 8. Let's say that it is an ln and I forget and I accidentally use this rule instead of the ln rule. Let's just pretend. So my u prime on the top would be a 10x. Over my u on the bottom would be a 5x squared plus 2. And then I'm going to multiply that by the natural log of the base, which for an ln is an e. Okay, well think about, what is the natural log of e? Natural log of e is really just a 1. So technically, this is still right. You just don't really have to put the ln e if it's a base e. Same for this one. If I'm taking the derivative of that, it's going to be e to the 2x5 plus 7x multiplied by, then I take the derivative of the core, which is 10x4 plus 7, times, and then if I were to multiply by the ln of the base e, well, what's the ln of e? Ln of e is really just a 1. So it doesn't matter if you put the ln if it's an e base. But if it's a non-e base, then you need to make sure to do that. Okay? So, going back to your notes, we're going to work through a couple more of the proofs that we've been doing in class. So yesterday we did them with trig. So today we're going to be doing with exponentials and logs. But the goal is that after we finish our couple of examples in the notes, we can look at the homework for a little bit. So let's say for our first one that we are taking the function y equals 5 to the x plus 1. And let's say that our x value here is going to be negative 4. Okay? And so your instructions are to prove that the slope of f of x is the reciprocal to the slope of f inverse of x. Okay, same thing we've been doing. So first thing I need to do is complete the ordered pair. So I'm going to take my negative 4, plop it in right there. So I'll have y equals 5 to the power of negative 4 plus 1. Okay, well, that's really 5 to the negative 3 when I combine my exponent up there. And then hopefully you remember that whenever you have a negative exponent, that's going to turn that term to go into the denominator. So I'm going to take my 5 to the negative 3. I'm going to write that as 1 over 5 to the 3. Now, hopefully you remember from a million years ago, okay, 5 squared is 25. Times by 1 more, that's 125. So my point for this is going to be negative 4, 1 over 125. Okay, from there, remember my second step after I complete the point is to take the derivative. So next I want to take the derivative. Okay, we'll look back at your original equation. It's right here. So if I want y prime, the derivative of 5 to the x plus 1 is 5 to the x plus 1 times. Then I need to multiply by the derivative of x plus 1, which is just a 1. And then I need to multiply by the natural log of the base, which is an ln 5. Then remember from here, I'm taking my specific x value, plugging it into x. So now I want to find the slope at my point, which means that I need y prime at negative 4. And then y prime of negative 4 is 5 to the negative 4 plus 1 times ln 5. One more simplification step here. Negative 4 plus 1 is negative 3. So it's 5 to the negative 3 ln 5, which is ln 5 over 125. That is the slope of the original function. So on the other side, we better get the reciprocal of that or we know that we did something wrong. So let's check it out. So coming back up here to the right-hand side, now that I've found my equation, I need to find my inverse. So I reverse the x and y, so now it's 5 to the y plus 1. Okay, well hopefully you remember that the only way to cross out a base 5 of an exponential is to use a base 5 of a log. So I'm going to write that a little bit bigger here. X equals 5 to the y plus 1. And then I'm going to take the log base 5 on both sides. Okay, and then hopefully you remember from pre-cal that log little 5 and 5, those guys cancel out, because logs and exponentials are inverses. Then my y plus 1 is going to come down to the front, equal to log little 5 of x. Then my last step, my plus 1 here, I'm going to bring it across to the other side, so that y equals log base 5 of x minus 1. Okay, from here, after I find the inverse, I'm going to take the derivative. Okay, well remember your derivative rule for logs. Y prime equals, it's going to be u prime over u times the ln of b on the bottom. So my u in this case is just an x. So my u prime is going to be a 1. I'm going to have an x on the bottom as my u. But then since my base was a 5, it'll be ln 5. Now, from here as well, you should notice that I have a minus 1 here, but technically that's a constant. And when I take the derivative of a constant, that term's going to go away anyways. So, this is my y prime. Now I need to take the derivative at my point. And remember that the slope at my point is going to be reversed from the ordered pair that I started with. So if I started with a negative 4 120 over 125, now it's going to be 1 over 125 comma negative 4. So remember that for a function and its inverse, the ordered pairs are always backwards. So then from here I would say, okay, well then y prime of 1 over 125 equals 1 over 125 times ln 5. And then I'm like, well, wait, if I'm dividing by a fraction, that's really the same as if I take my 1 over ln b and I multiply by the reciprocal, which would be 125 over 1. And then, multiply the tops, multiply the bottoms. 125 on top, ln 5 on bottom. And you can see that your functions' slopes are reciprocals, which is exactly what we were seeking out to prove in the first place. Okay. Alright, so we have 2 more examples. You ready? Turn the page. You can pause the video if you need to. If I'm going too fast, feel free to pause at any point. Next example, number 2. We are going to have the log y equals of 6 minus x, and we're going to do it at x equals 5. Okay, so first thing we need is the ordered pair. Well, then I'm going to take my 5, I'm going to plug it in right here. So I would say, okay, well then y equals the log of 6 minus 5. Okay, well that's really the log of 1. And then hopefully you should remember that from pre-cal, anytime you want the log of 1, let's say that you don't know what that is here. Let's just pretend like you have no idea. So if this is a y on this side, let's say I'm trying to really solve for y and I don't know how to do it. A log with no base is technically a base 10. So if I have a log base 10 over here, I'm going to raise both sides to be a power on a base of 10. So now I have this, 10 to the y equals 10 to the log 10 of 1. And then from here, like we talked about, okay, 10s and log 10s cross out because those are inverses. Well, then I want to know when 10 to the y is 1. Well, think about the only exponent that can turn any base into a 1 on the other side would have to be 10 to the 0 equals 1. So y is 0. So my ordered pair, my y is 0, my x is 5, then my point is 5, 0. Okay? But also, I would say, in general, you should know that anytime you have a log of 1, the answer is going to be 0. Okay, so I've taken my function, now we're taking the derivative. So I want y prime. Remember, derivative is u prime over u ln base. So my u prime for this guy here, think about it. If my u is a 6 minus x, let me write this out. Okay, then my u prime, the derivative of 6 is 0, but the derivative of negative x is a negative 1. So I'm going to have negative 1 on top for my u prime. Then my u is a 6 minus x. And then the ln of my base, remember what we said, anytime that my log doesn't have a base, it counts as a log 10. So I'm going to have to multiply an ln 10 here at the end. Then from there, I'm taking my x value 5, and I'm going to plug it in. So I want y prime at 5. Well, that's negative 1, 6 minus 5 times the ln of 10. That's negative 1 over 6 minus 5 is 1, ln 10. Okay, that is my slope. Okay, let's do the other side. Pause it if you need to, or if you have any things you need to go back and look at. Okay, other side, our first step is to find the inverse. So remember, to find the inverse, I'm going to switch x and y. So I'm going to have x equals log little 10 of 6 minus y. So hopefully you remember, to cancel out a log 10, I need to 10 both sides. Okay, then 10 and log 10 are going to cross out. So I have 6 minus y equals, and then I have 10 to the power of x. Then from there, I have this 6 in the way, so I'm going to minus my 6 across. Notice I cannot minus 6 from 10. 10 is the base of that exponential, so that's basically untouchable at this point. So 6 minus 6 crosses out, negative y equals 10 to the x minus 6. And then I have this negative here, so I'm going to divide by negative 1, negative 1, negative 1. So I have y equals negative 1 in the front, 10 to the power of x, negative negative here is really a plus 6. Now we're ready to take the derivative. So remember, my derivative, y prime equals, the derivative of 10 to the x is going to be 10 to the x again, then multiplied by the derivative of x is at times 1. But then because it was not a base e, it was a base 10, I have to put in ln 10 on the end. Then remember, this was a plus 6, derivative of plus 6 is 0. Also, I'm realizing that I made a mistake here. In my very front term, that negative 1, when you take the derivative, that negative is still out there. Now, that's not a negative 10. That's a negative in front of the base 10. So another way that you could rewrite that to make it not confusing is negative 1, 10 to the x, ln 10. And then from there, remember that whatever my point was for the original, my point for the inverse is reversed. So if this side was a 5, 0, this side is a 0, 5. And then I'm going to take my 0 and I'm going to drop it in for my x right there. So if I want y prime of 0, that's going to be negative 1, 10 to the 0 times ln 10. Okay, but remember what we said, anything to the 0 always comes out to be 1. So if that's negative 10 times, or negative 1 times 1 times ln 10, then that's really negative ln 10. And how else could I rewrite that? Ln 10 over negative 1. Okay, remember that it doesn't matter if I put the negative 1 on the top or on the bottom. Okay, technically these are the same. Okay, I can put my negative 1 on the top or the bottom. It does not make a difference. Okay? Alright, we are going to do one more left. Last one, then we'll look at your homework. Okay, so I am turning the page. We're going to do example number 3. Okay, example number 3 is going to be y equals e to the 4x. and our point is going to be x equals e to the 12. So first thing I'm going to do is say, okay, well, and actually, hang on, I wrote this wrong. That should be y equals e to the 12. So instead of giving me the x value this time, they're giving me the y value instead. But remember, step 1 is for me to complete the point. So if they give me the y value, I still need to go back and find the x value. But when I plug that in, I'm going to plug it in on y's side. So I have e to the 12 equals e to the 4x. Well, from there, remember, how do I get rid of an e? E and ln are inverses of each other. So ln and e are going to cross out. So gone, gone, 12 equals. Other side, gone, gone, 4x. Divide by 4 on both sides, x is 3. Now, if x is 3, that gives me my entire ordered pair. It's 3 comma e to the 12. So, from here, we are going to take our derivative, y prime. Now remember, if my equation is e to the u, then the derivative is going to be e to the u times u prime. Now, technically there's an ln of the base, but if it's an ln base e, remember what we said, ln of e is really just a 1. So I don't have to put it, although I could if I wanted to. So I'm going to have e to the 4x multiplied by 4. Okay, then from there I want y prime at my x value, which is a 3. So I want e to the 4 times 3 times 4, which is 4e to the 12. Remember, that is the slope. From there, we're going to work the other side. So if I got 4e to the 12 over here, I'm hoping to get the reciprocal of that over here. So step number 1, I need to find the inverse. So I'm going to let x equals e to the 4y. To get rid of a base e on my y side, I'm going to ln both sides here and here. And when I ln and e, these guys are going to cross out. I have 4y equals ln x. Then to get rid of the 4 in the front, I'm going to multiply by a 4th and a 4th. 4th and 4 cross out, y equals 1/4 ln x. Okay, next I want the derivative. So after I take the inverse, I take the derivative. Okay, well, the derivative of ln x is 1 over x. Still have a 1 over 4 in front of that. Then from there, I'm going to take the slope at my point. Now remember, when I take my point, since this is the inverse function, this ordered pair is going to be backwards. So instead of being 3e to the 12, it's going to be e to the 12 comma 3. And so when I take the derivative, I'm plugging in an e to the 12. Well, then I'll have 1 over 4 times 1 over e to the 12. And then remember, how do I multiply fractions? Straight across the top, straight across the bottom. So I have 1 over, 1 times 1 is 1, and then 4e to the 12 on bottom is 4e12. And then look at them. They're reciprocals. Okay, so you have proven it. Good job. Okay, so we're at about 23 minutes. So let's take a look for me, please, back at your homework 8 that you should have picked up today. So next one that I'm going to look at here, let's take a look at number, let's do number 2 and then number 4. We'll knock these out. So this is off of homework 8. So whenever you see all of these 8,000 steps, you're just trying to prove what we were proving in the notes. So let's say that I'm doing number 2. First thing I'm going to do is complete the point. So I'm going to take my half, plug it in right there. So I'm going to have y equals the inverse sine of 2 times a half. Okay, well that's the inverse sine of 1. And then I'm going to think about on the unit circle, where is my sine going to be 1? Okay, well remember, on the unit circle, it goes cosine comma sine. So if I'm on the circle here, I need my sine to be 1. That's my y value. Well, then that would be at pi halves. So I know that this is going to be pi halves, and my ordered pair then is going to be a half pi halves. Then from there, I'm going to take the derivative. Y prime equals, I'm going to use my rules sheet. So the derivative for inverse sine, okay, let me put my paper up here. Okay, you're going to see it's right here. Okay, so it's going to be u prime over square root 1 minus u squared. So if this is my u in here, then my u prime is just a 2. And then I'm going to have 1 minus u squared, which is a 2x squared. And then from there, I'm going to plug in my half. So I have 2 over square root 1 minus, now think about, if I put a half in here next to my 2, what's half of 2? Half of 2 here is going to give me 1. And if I do 1 squared, that's another 1. So then if I do 1 minus 1 on the bottom, I have 2 over 0, which is undefined. Curious. Let's see what happens on the other side. Okay? Let's see, shall we? Okay, so first thing I need to do is find the inverse. So I'm going to do x equals inverse sine of 2y. Then to get rid of the inverse sine, I'm going to have to sine both sides. So put a sign here, put a sign here. Those guys cross out. I have 2y equals. Then I have sine x. Hey. Okay, then from there I have to divide by 2 on both sides, which is the same as multiplying by a half. So I have a half sine x. Then from there you're going to take the derivative. Derivative of sine x would be a half cosine x. You're good, you can sit down. And then from there, I'm plugging in my ordered pair, but remember that for f and f inverse, this point is always backwards. So what that means is if that one's a half pi halves, this one is going to be pi halves, comma, a half. And then from there, I'm going to take my pi halves, I'm going to plug it in right there. So if I want y prime of pi halves, that's going to be a half of cosine pi halves. And cosine pi halves is 0. And if I do 0 times a half, that's 0 over 2. So obviously you can see at that point that those did come out to be reciprocals. Okay? So anyway, I ended up running out of time, but you can do 4 on your own. Remember that all of your homework for today, tomorrow, and the next day, they're all going to be due after Thanksgiving break. So they're going to be due on Wednesday. And that's just to give you some time. Homework 7, 8, 9. That's just to give you time to attend tutoring if you need it. Okay? Good luck.